All right, we're back. I'm back. And we are going to tackle question number 3, which involves computing the internal rate of return and net present value for each project. So let's start with the dome. And I've already created a spreadsheet for the dome. So looking at these numbers, so we need our cash inflows for the 8 years, and we've got our cash outflow, which is at time 0, okay? And so the 8,300 comes from here, the net capital spending, that's our outflow. And then the operating cash flow, this is best, likely, and worst, is equal to H16. Here's H, and here is 16. So 19,208, that's where that number has come from. That's where this number comes from. This number is B16, so this is the most likely case, 15,466. And then 9853, which is the worst case, which is right here. All right, so here's our cash outflow. Here are our cash inflows. Okay. Then we can do a net present value longhand. And what I did was I found the present value of each cash flow. Of course, the cash outflows are at time 0, so they are the present value. So we're going to take the cash inflow from year 1, and we'll divide it by 1 plus K, and K is 11%, and that's on page 75. Patsy's after-tax cost of funds, 11%, so add 1 to it and raise it to the year. 1 through 8. So, and then drag that out, and drag that formula out, and bada bing, bada bum, bada boom, there you go. So under the base case scenario, the net present value is equal to the sum of the inflows, okay? The sum of the inflows, C9 through J9, so here's C9 through J9, plus B9, which is plus a negative 8,300. We can also use the NPV function in Excel, and we put our discount rate there, then we put the cash inflows there, and then we have to add the cash outflow. That's how it works. And then we can do the same thing for the likely case. So we have to find the present value of the likely cash inflows, and so add that up, the inflows, the sum of C10 through J10, which would be here, subtract out the 8,300. Same number comes up when I use the Excel function. And then under the worst case scenario, same thing, we find the present value, so we get C6 divided by 1.1 raised to the C2, which is 1, and we drag that out, and then we add up the cash inflows, subtract out the cash outflow, and we get 44,265. Now, to be honest with you, I'm not sure where the problem is with this number right here. Either I'm $2,000 too high here, or I'm $2,000 too low here, and I'm not sure. And I will give you, what do I want to give you? I'll give you, how many points will I give you to find out what the problem is, why this number, one of these numbers is off, or maybe they're both off. These numbers all look the same, which is good, but this number is off slightly, and I'm not sure what the problem is. So I'll give you credit for, I'll add 3 points to your exam grade if you can tell me what the problem is there. Now, you cannot do this for internal rate of return. You have to use the function. Now, you could use the cash flow keys on your calculator to find the internal rate of return. You could use them to find the net present value. Okay? So you might want to do that. You might want to use your cash flow keys to find the worst case and see what the problem is, see what you come up with, whether you come up with this number or this number. But for internal rate of return, you have to use the function or your calculator, and so the function is B4, so we're looking at these cash flows that have not been discounted. So we have B4 to J4, and then we have to give a guesstimate for the discount rate, and I always put 0.1, and I came up with 231% internal rate of return in the best case, likely case, and worst case for the dome. Now let's do the bed. So we're going to go ahead and do this for the bed and see how it works out for us. So the cash outflow is equal to the $3,000, and we'll go ahead and format it this way, and we want that to be a negative number, so we're going to multiply it by a -1. There you go. And then we'll copy it, let's say equals this, and that. Actually, we don't need it there. Boom. Ah! Sorry about that. Let's go. Well, let's do this. Boom. Escape. 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 Let's just move this right here. And then equals this. And move it there. And there we go. Okay. Now, so the cash outflow under the best case scenario, or inflow, I'm sorry, under the best case scenario is 14,230. Okay. Now we have to anchor that. So let's go ahead right here and hit F4. Boom. And scroll it out for 5 years, because it's a 5-year project. We'll get into how to reconcile the difference between the 5-year project and the 8-year project in question 4 and 5. Questions 4 and 5. All right, likely case is equal to 11,420. Let's go ahead and anchor that right here. Alright, scroll over here. Alright, and the worst case is equal to 7205. We'll anchor that. F4, and we can scroll it out here. Okay. Now, let's find the present value, and it's going to be equal to that, so we're good there, and we can scroll that down. The 3,000 comes out on the front end. Okay, now, the present value is equal to our cash inflow divided by 1.11 raised to the year, right there. Okay, so we'll scroll that out there, and here's our net present value that we create over a 5-year period. Okay, then we have equal to that cash inflow divided by 1.11 raised to the year, and we'll scroll over here with that, and then equal to that divided by 1.11 raised to the year, and we've got this. Scroll over. All right, so our net present value is equal to the sum of the present values of our cash inflows minus our outflow. And so we can see that the net present value is goes from roughly 50,000 down to cut in half. So the net present value that we create in 5 years is much smaller than the net present value we create in 8 years up here. Okay, and here's our internal rate of return numbers. Let's see, B through J, so we're good there. And just for grins, let's go ahead and calculate. Well, let's do this. NPV, equals NPV. All right, the rate is 0.11, and comma, and the values are, no, the values are here. Yes. And then we'll add this negative number here, and hopefully we get the same number, and we do. Let's see what happens when we scroll down, when we drag this down. Now the numbers add up the same. Look at that. That's so weird that the numbers are the same here and here, but they're not the same here and here. Something weird is going on. Leads me to believe this is the number that is wrong. Which means this number's right, plus B11. So it's got to be in here somewhere. Wait a minute. This number, let's see, 9. Yeah, it's got to be in here. 9853. I don't know. Y'all try to find it. All right. Our internal rate of return is higher for this project. Okay. So let's go ahead. We can do a break even or payback. I'm sorry. Payback. Let's say for the dome, and for the bed, and the payback is equal to, for the dome, is equal to the cost of the dome divided by, let's see, well, let's do best case, and is equal to the cost of the bed divided by best case, percent, and that's good enough there. So this is the best case. Insert, and we'll call it best, most likely, and worst. And let's go ahead and make sure those are all centered. Go ahead and bold that. And likely is equal to the cost divided by the operating cash flow. And it's equal to the cost divided by the operating cash flow. and is equal to the cost divided by the operating cash flow, and is equal to the cost divided by the operating cash flow. So let's see what we got here. So even under the worst case scenario, in less than half a year, we pay the bed back. Okay? Takes a quarter of a year to pay under a likely. So we make it up pretty quickly. What else? Payback, net present value, internal rate of return. That's best case, likely case, and worst case. All right, so right now, if we don't make any adjustments, we would buy the dome because we'd make a bigger net present value in all circumstances. Okay? But the problem is that the bed has a 5-year life and then it has to be replaced, and the dome has an 8-year life. So we're going to have to make an adjustment, and we will do that in the next video. So you need to be researching how, and this was a participation question, how do you adjust for two mutually exclusive projects that have different useful lives? How do you make that adjustment? All right, we'll take that on in the next video, which will be due on Wednesday. Peace out. Shalom.